Welcome to ChemDoodle Shorts. I'm Mary, your ChemDoodle Pro. Let's learn about the RNS configuration. Enantiomers are stereoisomers that are non-superimposable mirror images of each other, kind of like your hands. If you put one on top of the other, they don't line up. They're not the same. So how do we differentiate these molecules? They have the same atoms and connectivity. They are both bromochlorofluoromethane. The key is defining the chiral center. Here, the carbon with 4 different groups attached as either R or S. To better visualize these molecules and the RS configuration, let's look at bromochlorofluoromethane in 3D. It has a tetrahedral molecular geometry, but which enantiomer is it? To designate absolute configuration, R or S, the Ingold-Prelog rules of priorities are used. First, assign priorities to the 4 atoms bonded to the chiral carbon. The atom with the higher atomic number has priority. Here we have hydrogen, fluorine, chlorine, and bromine. Bromine has the highest atomic number, 35, so it's assigned priority 1. Chlorine has the next highest atomic number, 17, so it's priority 2. Fluorine has a lower atomic number of 9, so it's priority 3. Hydrogen has the lowest atomic number of 1, so it has the lowest priority, 4. Next, orient the lowest priority group, in this case the hydrogen, away from you. Last, draw an arc from priority group 1 to 2 to 3. The arrow direction is clockwise, so the stereocenter is R, from the Latin word rectus for right-handed. To resolve absolute configuration in ChemDoodle 3D, select the structure. Then select the molecule menu, stereochemistry, and assign RS KIP. This enantiomer is R-bromochlorofluoromethane. The other enantiomer is S-bromochlorofluoromethane. After assigning KIP priorities and orienting the hydrogen, the lowest priority group, away from us, the arrow direction is counterclockwise. The stereogenic center is S, from the Latin word sinistra for left-handed. Let's consider another molecule, butane. It consists of a 4-carbon backbone with a terminal triple bond. Let's make this carbon a chiral center by changing one of its hydrogen atoms to the hydrogen isotope deuterium. Now there are 4 different groups bonded to this stereogenic carbon: hydrogen, deuterium, a methyl group, and an ethynyl group. So is this chiral center R or S? Let's find out. First, assign KIP priorities to the groups based on atomic number. With an atomic number of 1, hydrogen has the lowest priority, but there are 2 different hydrogen isotopes. When considering isotopes, the atom with the higher mass number has priority. This hydrogen atom has a mass number of 1, so it has the lowest priority, 4. Deuterium has a mass number of 2, so it has higher priority than the other hydrogen atom, but not higher than the other 2 groups. Its priority is 3. Now, let's determine the priorities of the methyl group and the ethynyl group. In both groups, a carbon atom is bonded to the chiral carbon. It's a tie, so we continue on and look at the atoms attached to those carbons to find the first point of difference. To better understand, let's show the implicit hydrogens bonded to the carbons in these groups. In the methyl group, hydrogen, hydrogen, and hydrogen are bonded to the carbon. In the ethynyl group, another carbon atom is triple bonded to the carbon. In the context of assigning priorities, we imagine that the triple bond translates into the carbon being bonded to 3 carbon atoms. Now we easily see the first point of difference between the methyl group and the ethynyl group. Carbon has a higher atomic number than hydrogen, so the ethynyl group has higher priority. It is priority 1, and the methyl group is priority 2. With all the groups assigned a priority, let's orient the lowest priority group, the hydrogen, away from us. Drawing an arc from priority group 1 to 2 to 3, we see that the arrow direction is clockwise. This stereocenter is R. The RS system is an unambiguous and systematic method of determining absolute configuration of molecules. First, assign KIP priorities to the substituents on the chiral center. Then orient the molecule with the lowest priority group away from you. Last, draw an arc from priority group 1 to 2 to 3. If the arrow direction is clockwise, the chiral center is R. If it's counterclockwise, it's S. Thanks for watching ChemDoodle Shorts.